All right, good morning. We are looking at sample data for Accuracy and Precision Lab. So for my remote students, I made a video showing the students actually performing the lab, but it did not give you any data numbers. So it shows you how to use the instruments and what we had to do, but it didn't give you any data to help complete the lab. So that's what this quick video is about. Here's some sample data. So what you're going to do is just copy this into your data sheet. So I'll have this up here and you can pause it, and you're just going to copy all these numbers that you see here. You're going to copy them right into your data sheet. And it goes all the way down to the micropipette here, you can see. So I'm going to pull that back and talk for a minute or two, and then scroll it down so you can get those last few numbers. And let me hide that. So there you go. That gives you a little more space. All right. So what you're going to do with these numbers is you are going to determine the density and then the average density using the mass and volume that you see here. Okay. So we have temperature, and the reason we have that temperature is because water has different densities, slightly different densities at different temperatures. So I'm saying the temperature is at 22, and here's the accepted or known density of water at that particular temperature. So you'll need to make sure you copy these numbers in, and then all of these. Please make sure you keep the decimal places, okay? Because that was the other point of doing this lab, is to show you that a beaker, you had to really estimate to get to that volume of 1 milliliter. And because we're estimating, we cannot say that it has a decimal point. With a graduated cylinder that has the markings on it, the graduated labels on it, we can say with accuracy that we measured to 1 decimal place. The pipette to 2 decimal places. The micropipette to 3 decimal places. The top loading balances all measure out to 2 decimal places, whereas the analytical balance, it's more precise. It can measure out to 4. So please make sure you keep those decimal places. To find density, you need to remember that density is mass over volume. So all you're going to do is you're going to take the mass number, 5.55, and you're going to divide it by the volume of 1. So that density is going to be 5.55. Whoops. Okay. You're going to put that in the blank, and you're going to do that 3 times. Okay, we've taken 3 measurements. We do it 3 times. Then to get the average density, what we are going to do then is we're going to take those 3 density numbers and we're going to add them up and divide by 3. And that's the one number that will go in there. So you'll have 3 numbers. So 3 measurements. Whoops. You'll have 3 measurements that will go in here, 3 densities that will go in here. And only 1 density, 1 number that will go in there, and that's going to be the average, okay? And that's pretty much it. As far as decimal places, I think we need to, probably 2 decimal places is going to be all you're going to need to carry out. So just round it to 2 decimal places. We will be talking about significant figures in today's, this is Wednesday, in today's worksheet. So you'll get practice with significant figures there. So not really worried about it in this particular lab. When you get done filling in the chart, there is a, let's see if I can go, well, I guess I can't. Wait a minute. Oop, there we go. There are post-lab questions that you will need to answer. Hang on. Okay. Sorry. It got a little ahead of me. All right, so there's our data table. You'll fill that data table in, and then you will determine the percent error, which is, we did a video on that earlier. And then you will have analysis questions to answer. It looks like there are 8 of them, 9, 10 of them. Okay. On the standard deviation one, you're just going to plug into that formula and use that formula to get your standard deviation. Okay. So let's see where we left off, where I need to slow things down for you. All right. So that should be enough time to copy the first part of that table down. And here is the second part of that table. So I'm going to give you a minute or two to copy that down. And like I said, when you're done getting your density and your average density, you will then go on to find the percent error for the top loading balance and for the analytical balance for beakers, pipettes, or whatever that table said. I think it's beakers, pipettes, graduated cylinder, and micropipette. Then you will use that information. You will answer all of the analysis questions underneath. Okay. So we're not going to do a lab report on this one necessarily. And I'm also not necessarily going to be checking it for accuracy. We're just going to be answering the questions and doing those calculations there. Okay. All right, so that should be it. And you should have the data that you need to complete the lab at this point. If you have any questions, let me know. And I think that's it. Have a great day.